Hello, and welcome to part two of my carbohydrates discussion on how to draw the various monosaccharides. My name is Dennis Roberts, and I am Dr. Chem Tutoring Service. The last video I showed all the variations of the D and L sugars along with the alpha and beta ring forms, where today we're going to show how you get from one of those structures to the other. So for this, we're just going to focus on D-glucose because the process is the same regardless of the sugar you are dealing with. And so remember, for a Fischer projection, you got to look at each chiral center individually. And at the chiral center, the left and right sides are coming out towards you. The top and the bottom will be going away. And that's true for every one of those chiral centers. So it's almost like each chiral center is giving you a hug, and these pieces are going backwards. That's the equivalent of looking at a bond line structure from this direction, where the wedge and the dash would be here. The wedge and the dash on your left and right, this is my head, are coming out towards me, and the things that are above and below my eyesight are going away from me. So the way you go from, we'll go from one to the other and then back again. The way to go from a bond line structure to the Fischer projection is you want to make sure you place yourself so that your head is to the top of the sugar, which is the one carbon that is the carbonyl carbon. And then my feet will be down towards the CH2OH, like so. Once you do that, you then want to do it from both sides, because notice when you do this, these carbons are pointing out toward you, whereas these carbons are pointing out towards you when you're facing the other way. So when I number my carbons, carbonyl being 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, the chiral carbons are going to be 2, 3, 4, and 5. For 2, the way this structure is drawn, I have to look at the bottom because 2 is coming out towards me from this side. So I have to look in the direction that is kind of pointing, which is towards me on the bottom. When doing that, here we have a dash for the OH. You have to almost put yourself in the position of that person. Where is that dash? Wedges are coming out towards us, dashes are going away. So if I'm laying down here, the dash that's going behind the board is going to be not the ear that's shown, which is my left ear, but my right ear, which is behind. So the second carbon on a Fischer projection, that dash is my right ear. It's going to be on the right side. Now looking at the next carbon, 3, it points up towards this person. He's looking at that carbon. Now the OH is behind again, but notice I flip positions. This is now, as I look this direction, this is my right ear. If you don't see that, try to put yourself in his position. Which ear would that be if you're looking the way he's looking? This is my right ear. So the wedge would be on his right side. The thing going behind the dash would be the ear back behind, which is his left ear. Then carbon 4, again, we look in the view of the person down below because it points that way. Carbon 4 is a dash. The dash relative to this person is behind the board, which is the ear you cannot see, the right ear. And then last on carbon 5, we have a wedge, which is coming out towards us, which is the ear we can see on this person, which is his right ear, so it's on the right. Because that is on the right, in the Fischer projection, it is a D sugar. So that's how you can go from a bond line to a Fischer. Now there are some shortcuts. The shortcuts are, you should notice a pattern. When I'm looking from the top or when I'm looking from the bottom, I am rotating. So looking at it from this way, as opposed to looking at it from this way, here's my ear, Notice that here his right ear is showing, down here your left ear would be showing. So everything's flipped. So if you really just have to find the first one. This carbon 2 for this guy is a dash, which is his right ear. So what you can say is dash equals right, which means the opposite wedge would equal left for the bottom. Anything up here would be the opposite. Dash would equal left, wedge would equal right. So once you find the first one, you can infer all the others. But if it helps, you can draw everything out just to be safe. Now keep in mind, when you draw D-glucose, I drew it one way. Your professor could show it a different way, where maybe they rotated it so it looks like this. Or they could have flipped it around to look like this, where the carbonyl is on the left side. And if I were to rotate it around, everything would kind of rotate as well to keep the same stereochemistry. And let's verify all of these are the same by drawing the Fischer projections. And we're going to do it just by drawing one person. So let me move this so I have space. So for this one down here, to verify it is in fact D-glucose, what I'm going to do is I'm going to put my person up here. Again, your head should always be towards the carbonyl, feet by the CH2OH. Here's my ear. If I'm laying this way, that is my right ear. Looking at carbon 2, what do I notice? It's a wedge. It's coming out towards us, which would be like his right ear coming out towards us. So here, the right would be a wedge, and then the dashes would be left. On the bottom, it's flipped. Wedge would be left, dash would be right. So on the top, carbon 2, wedge right, wedge right. Carbon 3, it's on the bottom, it flips, so wedge left, wedge left. Up above, we go back to this top format, white wedge is the right. And then on the bottom, dash is on the right. Again, let's try it another way if the sugar is drawn differently to begin with. Let's look at this top one I drew where I rotated this vertically. Not flipped, rotated. So I should have the same structure. And I can verify now, look, my head is going to be on the left. My feet are down here because the head should match the carbonyl, because that is the top of my Fischer projection. I look at carbon 2. It's on a wedge. The way this guy's laying, the ear that's coming out towards us, like the wedge is his right ear. So again, wedge equals right, which means dash would equal left. The other side would be opposite. Wedge equals left, dash equals right. So on the bottom, wedge right, top, wedge left, bottom, wedge right, top, wedge left, but this is a dash, so it's dash right. So that's how you go from the bond line structure to the Fischer. The Fischer to the bond line is going to be very similar. We would start with the Fischer projection, and we would draw out our bond line. You can start that CHO, that aldehyde, any way you want. I'm going to start it here. And that's going to be carbon 1. Then I have 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 6 has the OH there. That is that. So now I need to find the chiral centers of 2, 3, 4, 5, and 6. You do the same thing we did before. Your head is going to be down here for this guy, because that's the one pointing towards you. And then for the top, you're looking at all of these points, 3 and 5. But we're just going to start with 2. Looking at 2, if this is the person, this is the back of his head because we're looking at the Fischer projection. We have his left ear and his right ear. Remember when we look at the Fischer projection, the left and the right are wedges. They're coming out towards us. When I look at this OH is on my right side. So when I'm laying down here, my right side is going to be going away from the board, which is a dash. Now, again, you can do the whole scenario looking at 3 now. The OH is on my left ear, but I'm looking from up here, and my left ear is behind the board. I can't see it, so it's also the dash. But once you figure out that first one by looking at this, if I said that the right side here was a dash, we alternate because we're always flipping as we go down the chain. So dash, 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 wedge, 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 wedge. So if I were to draw this, my OHs would be from 2, 3, 4, and 5. 2 would be a dash, 3 would be a dash, 4 would be a dash, and 5 would be a wedge. So hopefully that clears up how to draw these things. Again, if you try to memorize a route, be careful. It's tricky because when you memorize a route one specific way, you may be memorizing it for when it's always drawn in this notation where the carbonyl is always on the right and the carbonyl is kind of in this direction. Which if you do a memorization of, carbon 2 is a wedge is on the left always or something like that, that's not true if they draw it like this. So keep in mind, it's not best to just memorize, wedge is dash or wedge is wedge is on the left and dash is on the right because it may not always be. You always want to at least draw the structure once where you have the person in the view, decide where's the wedge and the dash on that second carbon, and then alternate as you go down. If you have any questions, feel free to send me an email. I'll be happy to answer them. If you have other examples you want to go over similar to this, I can walk you through another one. It doesn't have to be a hexose like these are, 6 carbon chains. It could be a pentose or something else that you want explained, and I could probably do videos on those as well.